Hello, my name's Simon Timperley. Welcome to Food Safety Fridays. Today's special guest is Anne-Marie Joyce from Safe Food 360, and the subject today we're going to be talking about is understanding the difference between PRP, OPRP and CCP, an introduction. So if you don't know what all those acronyms mean, you soon will. So welcome, Anne-Marie. Nice to have you back again.
Hi, Simon. Thank you for having me back. Looking forward to today's topic.
Good. And in tradition of Food Safety Fridays, can you tell us where you're joining from today?
Yes, I'm joining from County Meath in Ireland. So for those of you who don't know, it's beside Dublin. Everyone knows Dublin, so yeah.
Yeah, of course they do. And I'm from the north of Manchester in a place called Ramsbottom. Anyway, you tell us where you're from in the sidebar. Type in, and there's about over 2,500 people registered today. So we're expecting already 464 online. So we're going to see that scrolling quite fast. But tell us where you're joining from. It's always nice to know. I'm going to play the sponsors ads now, and then we'll come back for the presentation afterwards. Okay. See you in a couple of minutes.
In the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our client's side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Okay, thanks to our kind sponsors who help to bring these webinars. You'll get the recording afterwards, the slides and a certificate of attendance. So please leave your questions till at the end of the PowerPoint, because otherwise they'll just scroll away and you'll be wasting your time. So please leave them till the end. Okay, so I'll be back later to moderate the Q&A, but for now, hand you over to Anne-Marie.
Thank you, Simon. So, hello everyone. Thank you for joining today. My name's Anne-Marie Joyce, and I am the training executive in Safe Food 360. Today's topic, as Simon mentioned, is an introduction to PRPs, CCPs, and OPRPs. Just a little bit about Safe Food 360. Safe Food 360 is a food safety and supplier management system or software, and it was originally developed by food safety experts, and the professional services department, which I'm part of, are all food safety experts from different areas of the food industry. In Safe Food 360, our mission is to be the leading provider of compliance and professional services to the global food industry. And we want to be essentially a one-stop shop for your food safety and supplier management. If you want to learn more about Safe Food 360, you can go to safefood360.com. Also, on our website, we have free resources such as white papers on different food safety topics, which you can download and read. And if you do have any questions on the software, you can contact my colleague Barry O'Neill, so barry.o'neill@safefood360.com, or if you're interested in a demo, also marketing at safefood360.com. So, as I mentioned, my name's Anne-Marie. I'm the training executive in Safe Food 360. My role is to train our customers on how to use the software. So let's actually begin. So today, the agenda is to look at what a PRP is, an OPRP, and CCP. So we're going to learn about what they stand for in just a moment. Then we're going to look at the differences between them and how we can actually determine these control measure categories, which they are. So we can do this using risk assessment and decision trees, which we'll look at today. So when we talk about HACCP, Hazard Analysis Critical Control Point, risk assessment and determination of control and control measure categories themselves are often aspects that confuse people. And hopefully today everybody will be able to get a little bit of clarity on the difference between these different control measure categories. Really, with HACCP, the basic principle is really to install within the process and operation some control measures which are appropriate for the specific hazards identified and the risk they pose to final consumers. And HACCP requires you to identify these potential hazards, then determine the significance of these hazards, which we'll talk about later on in the slides. So to determine the significance by applying risk assessment techniques, and the output of which is a measure of risk that then allows you to determine if you need controls and the category of control measure. So PRP, OPRP, or CCP. So let's firstly have a look at what a PRP is. A PRP, or prerequisite program, are usually general to your process and don't actually focus on a particular step in your process. So throughout the presentation today, I will be referring to ISO 22000, primarily because we are going to be talking about OPRP, which was brought in by ISO. So today you will see that we will be referring to this particular GFSI standard. So how does ISO define a PRP? A PRP is basic conditions and activities that are necessary within the organization and throughout the food safety chain to maintain food safety. So prerequisites are primarily aimed at preventing contamination and maintaining a hygienic environment. So PRPs are general to your process. They don't focus on a specific step in the process. So, for example, cleaning and sanitizing, these are activities that can be applied to all steps, all areas, and items within your facility. And failure of a PRP does not necessarily lead to an imminent food safety risk. However, perhaps depending on the nature of a food and its process, failure of some prerequisites might have more than just one minor impact on food safety. And this word failure is something we're actually going to see quite a lot throughout the presentation when we're looking at decision trees and so on. We'll see this word failure come up time and time again. So a PRP within your organization will depend on this, the area of the food industry you are in sectors such as the agricultural sector. PRP may also be known as a GAP, or Good Agricultural Practice. So in different areas in different industries across the world, PRPs can be known as maybe something different. So what are some examples of PRPs? Let's have a look. Here are a few examples. We got premises and structure. We want to get that right initially. Plant and equipment, cleaning and sanitation, contamination control, calibration, maintenance, supply chain management, training of personnel, pest control. These are all PRPs. So having PRPs in place is all about creating an environment suitable to produce safe and legal food products. And you can kind of see PRPs as a foundation, essentially. Some of you, if you have ever Googled PRPs and the difference between PRP and CCP, you may have come across a pyramid with PRP on the bottom, OPRP in the middle, and CCP on the top. So you can kind of consider your PRPs as a foundation, essentially. So now that we've defined PRP, what is an OPRP? OPRP stands for Operational Prerequisite Program, and it was originally brought in by ISO 22000. So how did they define it? What's their definition? An OPRP is a control measure or combination of control measures applied to prevent or reduce a significant food safety hazard to an acceptable level, and where action, criterion, and measurement or observation enable effective control of the process and or product. So what we'll be doing in a moment is we'll actually kind of dissect the definition of an OPRP and a CCP. We'll do that in a few minutes, because this can, by dissecting it and looking at it, it can help you understand it a lot better. Because when you see it like this, you know, it's a bit overwhelming, but if you actually just break it down, it can help you to understand what it is and what, in this case, ISO want. Just on that note, the definitions will maybe slightly vary depending on the GFSI standard you may have in place. So, you know, BRC version 8 may have a slightly different definition to ISO and SQF and so on. So just be aware of that. So essentially, an OPRP can be determined by using a risk assessment and a decision tree, which we're going to be looking at later on. And an OPRP is a control measure deemed crucial, but not considered a CCP. A CCP is a critical control point, which we're going to look at next. And it's crucial but not deemed a CCP, as perhaps there may not be absolute control over it. And also perhaps maybe further down your process, you manage the hazard identified. So we are going to look at an example in just a moment, but let's say, for instance, we have a magnet in our process, obviously there to deal with foreign matter metal. And then perhaps further down in our process, we have metal detection. So an OPRP, you may not actually have absolute control of it. So you may not have absolute control over your magnet, but further down the line, the hazard that you've identified, metal, will be dealt with at the metal detection stage. So that kind of helps you to understand an OPRP. They are dealing with significant hazards, but essentially failure of the magnet won't maybe automatically mean that a product isn't safe, because we've got metal detection further on. So OPRPs can be determined when you are conducting your hazard analysis. And as I mentioned, the failure of an OPRP doesn't automatically mean that a product is unsafe. So an OPRP can be treated like a CCP, but critical limits are not required. That's one of the differences between an OPRP and a CCP, which we will talk about in a few minutes. And you don't have to define critical limits with an OPRP. So let's have a look at some examples of OPRPs. Now, just be aware that your process, depending on your process and what you're producing, an OPRP for you might not be the same for somebody else, okay? So it will depend on a number of different factors. But here are some examples. We have temperature control, metal control, zoning, specific sanitation procedures to prevent cross-contamination at a certain part of your production line, and equipment sanitizing. So here are some examples of OPRPs and that somebody may have. Let's have a look maybe at some more examples. So magnet cleaning. So we have a magnet step to deal with the hazard foreign matter metal. And let's say, for instance, we have the magnet in our process, but further on, we will have metal detection. Cleaning at the magnet step can be considered an OPRP, an operational prerequisite program. We can do visual checks on the magnet, clean it, and test its strength, but critical limits don't have to be defined. So if we actually look at the ISO definition, we don't have to put critical limits in place. We can measure if we want, and we can do some observation as well. And while the magnet step is in place to reduce the level of the hazard, its failure in functioning won't cause an unsafe product from being produced, because in our example here, metal detection is taking place further on. So this is definitely one point that can help you understand what an OPRP is. It is important, and we're trying to deal with significant hazards, but if it fails, if there is a deviation, we do have metal detection further on. So this can help you to understand that. Another example is temperature control. So you might think, for those of you who may be familiar, oh, that's a CCP. Yes, in some cases it is, but in this example here, let's say we have raw milk coming in, we're storing it. There is always the possibility for growth of biological hazards such as salmonella and listeria. But if we have temperature control in place and further on down the process, we're going to pasteurize this milk, then temperature control at this receiving step, or this would be storage of the milk, then this could be considered an OPRP. It's a failure at this point might not necessarily mean that there will be a high food safety risk, because we will be pasteurizing later on. So these examples can help you understand what an OPRP is. Next, what is a CCP? This is actually probably the most popular or well-known of the three different categories we're looking at today. And a CCP stands for Critical Control Point. What does ISO define a CCP as? A step in the process at which control measures are applied to prevent or reduce a significant food safety hazard to an acceptable level, and defined critical limits and measurement enable the application of corrections. So similar to the OPRP definition, we have the word significant food safety hazard in here. So they're both dealing with significant food safety hazards, something we'll talk about again in a few minutes. It's important to understand that. And one difference here is the word critical limits. A CCP should have defined critical limits so that we can enable corrections. So a CCP is essentially a point. So CCP, we've got critical control point. So a point where control can be applied to food handling processes to reduce and prevent hazards from occurring. So a CCP is a point where absolute control of the hazard is. That's what a CCP is. And if a CCP is not carried out effectively, then food poisoning or foodborne illness could occur as a result. So again, just as mentioned, a CCP is a point or a process step. So it's specific to a process step that you have. It's not a general activity like cleaning or anything like that. It's process step specific. As mentioned, critical limits have to be defined. So if it was, let's say cooking or baking, we need to have maybe defined temperature limits and timing perhaps as well. And we can identify a CCP using risk assessment and then a decision tree, which we'll see later on. So next then we have some examples of CCPs like freezing, metal detection, pasteurization, cooking. So just to have a look at some of the differences. Well, firstly, just in relation to the difference between a PRP and OPRP. The difference between a PRP and OPRP is that OPRPs come from the hazard analysis as part of the process line, and PRPs essentially enable a safe environment, assuring that the produced product follows a safety method. So PRPs, they're not specific to one hazard, they're just there to maintain food safety. Then looking at CCP and OPRP, sort of dissecting a little bit the definitions. A CCP is a step or point in the process where control measures are applied. And for an OPRP, control measures or a combination of control measures can be applied. And with a CCP, we have to establish critical limits. With an OPRP, it's not required. We need to be able to measure CCPs. For OPRPs, we can measure as well, or we can use observation. And with a CCP, we need to be able to apply corrections. And that's why we have critical limits. So next, let's sort of have a look at the difference between all these control measure categories. So first of all, in relation to hazards, as we already mentioned, PRPs, they're not specific to one hazard. OPRPs and CCPs, they are specific to each hazard or group of hazards. Determination, so to determine what's a PRP, we can use our experience, we can reference documents, any GFSI standard we're working to, and we can also use our hazard when we're conducting our hazard analysis. Then an OPRP is based on the hazard analysis taking into account your PRPs, and OPRPs are product or process or process specific. And it's the same for a CCP. They are based on the hazard analysis and they are product or process specific. Next, critical limits. So for a PRP, we don't need to have any defined critical limits. For an OPRP, we need to have measurable or observable criteria, but critical limits aren't required. And with a CCP, we need to have a measurable critical limit. Monitoring, so enable to monitor these, we can monitor PRPs where relevant and feasible. OPRPs, well, the monitoring method and frequency shall be proportionate to the likelihood of failure and the severity of consequences. And for CCPs, monitoring method and frequency shall be capable of timely detection of any failure to remain within critical limits. If we have a deviation, for PRP, we'll put in place corrective actions or corrections. Rarely, if there is a deviation in a PRP or non-conformance, we don't need to take specific action on a specific product. If there is a deviation on an OPRP, it may or may not result in an action against the product. It will depend on the specific deviation. So for example, earlier on we had the magnet as an example. So if there was a deviation at that magnet step, maybe it wasn't cleaned correctly or something like this, it doesn't necessarily mean we might need to take action on a specific product, because further down the line we got our metal detector. A CCP, well, affected products should be identified and handled as potentially unsafe. So, if there is a deviation, we may need to put the product on hold or even do a recall. So determining control measures. So is it in a PRP, CCP, OPRP? How can we determine this? So when determining control measures, firstly, the specific hazards at each step are identified and characterized. This is then followed by a risk assessment to determine which hazards, if any, are significant. And significant hazards are then applied to a decision tree to determine if they should be controlled as an OPRP or a CCP. One of the benefits to actually ensuring that one of the benefits of actually, using a decision tree and following this is so that you don't have to use so much resources on hazards that are non-significant. So you save your resources for significant hazards. Then if we have a look at risk assessment, so risk assessment models help you to determine if a hazard is significant. Now, the term significant, we've said it a few times already, it is widely known but poorly understood. So the term significance is used simply to describe those hazards which present a real risk of impacting on the consumer. So significant hazard will have an impact on the consumer. So risk assessment, it's used to separate those hazards which require tight control from those requiring lesser control. And it can't be said that significance is an expression of risk. In food safety, risk is a measure of the combined severity of impact from a hazard and its probability of occurrence. So probability by severity. So in its simplest form, risk is expressed as being low, medium, and high, or high. When it comes to defining if a hazard is significant, risk is usually used. So for example, you can say that any risk deemed to be high and medium are significant, like we can see here on the screen. While low risk hazards are deemed to be non-significant. So if something's non-significant, maybe we're not going to deploy so much resources. So using a decision tree allows for a solid and logical approach to determine control measures and will also actually show an auditor how you arrived at your decision. So a decision tree can be used for this. As I mentioned earlier, GFSI standards set out requirements for determining control measures. And again, if we were to look at BRC version 8 versus ISO 22000, there may be some variation there. So it's important to know your GFSI standard and what it defines. So there are a large number of decision trees employed and cited in various standards. Probably one of the most common decision trees has been the Codex standard decision tree for HACCP. And the Codex decision tree focuses on whether the hazard should be controlled as a critical control point or not. But it's important to know that it doesn't assist in determining what type of control should be used where there is an outcome other than a CCP. So other robust models like the ISO 22000 model will account for PRPs and OPRPs as well. Just in relation to Codex, in 2020, there was an update to it. There wasn't an update since 2003. And in it, the decision tree was not included. They didn't add a decision tree into it in the latest version. And so the decision tree is no longer the only option you have when defining a CCP. You can actually use an alternate approach to identify a CCP. Now, what Codex does do is it does actually detail a number of points to consider when you're trying to identify a CCP. So there are lots of decision trees. We got Camden BRI, ISO. There's lots out there. And as I said, Codex is probably one of the most well known. But as I just mentioned, they did not include it in the most recent version, and they allow you to use alternate approaches. So what we're going to do is we're going to go through the ISO 22000 decision tree. So this actually is broken into two sections. Firstly, hazard assessment, which we see here, followed by selection and categorization of control measures. So we'll come back to that in just a moment. So hazard assessment. So the first question there is there a significant hazard at this step? If we say no, then we should apply PRPs, because if it's not significant, then we can just manage with PRPs. If we say yes, we move on to question 2. Is it necessary to apply control measures at this step? If we say no, then as you can see here, it mentions that a control measure could be perhaps in a subsequent step in the process. So for example, if we had a process step called mixing, and we've identified a physical hazard of metal, well, we would answer that question as no, because further down the line, we have metal detection. So there is a control measure in a subsequent step. Now, if we say yes to that question, we move on to question 3, and it asks, are control measures already in place? If we say no, then it mentions that we need to implement control measures by modifying the process and so on. But if we say yes to this particular question, we move on to the next section, which is selection and categorization of control measures. And the first question here, question 4, is there any failure of the control measure with a high risk for the safety of the product? So what it's basically asking is, if the control measure fails, will there end up being a high food safety risk? And there's a few things to consider, and they're listed there. You know, the effect on the hazard, control measure specifically applied to reduce to an acceptable level, any subsequent control measures, and so on. So if we actually say no to this, if the control measure fails and there is not going to be a high food safety risk, then this has been determined as a OPRP. So if it fails, there won't be perhaps a significant impact on the product. So we manage this as an OPRP. But if we say yes, that if the failure of the control measure was to happen, there could be a significant impact on the product, then we move on to question 5. And question 5 is it feasible to establish measurable critical limits and monitoring that enable timely detection and correction of a failure? If we say no, that we can't establish critical limits and we can't timely detect and correct failures, then this is an OPRP. And if we actually refer back to the definition of a CCP needs to have a critical limit in place. And so if we can't put that in place, this can be considered an OPRP. And obviously, if we say yes to that question, well, we got a critical control point to categorize the control measure as a CCP. So there's lots of different decision trees. This one here takes into consideration PRP, OPRP, and CCP then as well. So if we move on, here we have a new tool brought in by ISO, and it helps us to determine PRPs, OPRPs, and CCPs. So at the top, we have severity times likelihood of failure. As I said at the start, failure, it's something that can help you determine the difference between an OPRP and a CCP. So severity times likelihood of failure. And then on the left side, feasibility of detection and correction of a failure. So fundamental to understanding the CCP and or OPRP classification is that ISO distinguishes between two levels in assessing severity and probability. The first level is focused on assessment of hazards, and the second is focused on the assessment of the failure of control measures. CCPs are characterized by a high probability times severity of danger and a high probability times severity of failure, but have good feasibility for detecting and correcting this failure. So if we have a look at this here, so a CCP, the failure is high and the detection and correction is high. If we look at that and we sort of look at where we meet at CCP there on the top right. So the PRPs that you put in place are mainly aimed at preventing contamination and maintaining a hygienic environment, which we've mentioned today. And to achieve this, PRPs are applied as part of a program with a combination of measures that all contribute to food safety. So this implies that in many practical cases, the probability times severity of failure of a single requirement has only a minor impact on food safety. So the failure of a PRP, or the impact of a PRP failure is low because they aren't really controlling a significant hazard. So, sort of looking at the definitions again of PRP, OPRP, and CCP. OPRP and CCP are there to prevent and control significant hazards, whereas a PRP, it's like the foundation. And if we do have a failure of a PRP, it's not going to perhaps directly impact a specific product. So in the practice of safe food production, there are situations in which, despite a high probability times severity of hazards and of failure, the feasibility of measurements to detect and correct a failure is quite low. And in that case, we have an OPRP. So assessing the probability times severity of failure in ISO is fundamental to understanding OPRPs. A control measure that is administered as an OPRP controls a significant hazard, but failure of an OPRP doesn't necessarily lead to an unsafe product. So again, maybe referring back to our example before, it's for temperature control on receiving the storage of raw milk. Failure doesn't necessarily lead to an unsafe product because we'll be pasteurizing later on. So hopefully there has been I've given you some clarity around these different terms. Maybe just some key points to sum up. Understand the definitions of the control measure categories under the scheme you are compliant with. PRPs PRPs are basic controls or activities within your production facility. As I mentioned, they're like your foundation essentially. And OPRPs and CCPs are hazard specific and can be determined as being the control by using risk assessment and a decision tree. So I think now we can go to any questions that people may have.
Yep, we can. Let's just knock the slides off. There have been lots of questions all the way through, but I did say a few times just to leave it to the end, but let's see what we can do. Okay. Let's start with this one. What about metal detection? Does metal detection come under PRP or CCP, in your opinion? Or
so I guess it will depend. That's why you begin doing a hazard analysis, and obviously then going through the decision tree can help you determine that. I mean, I wouldn't necessarily say it's a PRP, maybe CCP, or depending on your process, maybe you have two metal detectors. One could be at the start an OPRP, and then further on, and your last one is CCP. It will depend, but I wouldn't. It will depend on your process, I think.
Okay.
Yeah.
Yep, it's good. Somebody's just asking, yes, Salawu, you will get a copy of the recording, a soft copy of the presentation and the certificate afterwards. Okay, so Michael Green is asking, I'll just highlight that for you. Is the main difference between OPRP and CCP that CCPs are the last part of the process that the hazard can be controlled, and OPRPs control the hazard, but there are other steps later in the process? That's exactly what you've just said, isn't it, with the metal detector?
Yeah.
Okay. Oh, that's good then. Right. Keck. For temperature control in OPRP, how to be not have a critical limit? Can you provide an example? So temperature control.
Yeah. So
okay.
So I know the definitions, they say you don't have to have for an OPRP, there doesn't have to be a critical limit, but that's not to say you don't use one anyway. So you can, you might, for temperature control in the example that I mentioned, there could be a critical limit defined, but the temperature control at receiving is an OPRP essentially, because if it does fail later on, in my example, there would be pasteurization. So you can actually manage an OPRP in the same way as a CCP if you wish. You can.
Yeah.
You can.
Okay. Okay. Another question from Vinod. Can I control hazards in my process through strict implementation of PRPs without any CCPs or OPRPs?
Yeah, good question. This depends on the product you're producing and the process, but yeah, sometimes there may not be any CCPs and PRPs defined, but it will depend on the product, the process, and that's why sitting down, doing your hazard analysis can help you to determine that. Yeah, there may not be. I mean, it will depend.
Okay. And then Afifa, I would like to know, if there's no critical limit for an OPRP, how observations can be done. Is it possible to have OPRPs but without records or a checklist?
So with the definition, you don't have to have critical limits, but you may have critical limits in place. OPRPs, they are dealing with significant hazards. So there will be, again, if we look at what needs to be done, there should be at least measurement or observation. So you would need to be recording and again, depending on what it might be, recording and doing checks. You might not be doing checks as frequently on it as you would do a CCP, for instance, or there may not be some sort of a monitoring process in place, like with temperature control. Maybe there's some system that sends off an alarm if it goes down by the critical limits, but you might not have that with an old PRP. But they are managing significant hazards, so there should be some form of, so you should be recording something, and
yeah, sure. John, is it possible that an OPRP can be downgraded to a PRP if proven via hazard analysis and validation of control measures?
Is it possible that an OPRP can be downgraded to a PRP?
If they prove through hazard analysis and validation.
Perhaps. I'm not 100% sure on this particular question.
So if the validation is like robust, is it? It's difficult, isn't it, without understanding the process and the logic behind it. I guess.
Yeah.
Okay. Thanks for the wonderful explanation of the difference in similarities CCP, OPR, and prerequisite. Okay, let's see this one from Ricardo. Can liberation analysis, i.e. microorganisms, allergens, be considered as a CCP? Are you familiar with that term, liberation analysis? I'm not.
No, no, unfortunately, no, I'm not.
Okay, we'll move on. If you can sort of rephrase your question a bit, Ricardo, with what liberation analysis means. Okay. So Martha is asking, what would be an example of a PRP and OPRP within a broker operation?
Oh, good question. Broker situation, yeah. I'd have to look into this and I mean, yeah, you're not directly handling the product.
No.
So ideally you would have the HACCP plan from your supplier.
Yeah.
That's a good question. I haven't seen too many broker HACCP plans.
Yeah. So we're talking a broker that buys in products and then just literally doesn't do any processing of it or anything, and just you're very much relying on the supplier controls and their HACCP systems because they're producing it, I guess.
Exactly.
Yeah. Okay. So Johanna is just asking for clarification. Is OPRP equal to CP?
Good question. Now, I'll have to look back at the definition of a critical point. I wasn't looking at it for this particular session today, but there may be some similarities. I'd have to follow up on that one. Just to look at the definition of CP.
Okay. Let's see. Okay, magnets from Sachin. Regarding the in-place magnet example, if a process doesn't have metal detection after the magnet, can the magnet be considered a CCP?
Can do, yeah, if there are critical limits in place, yeah. Can be for some people, yeah.
Okay. From Tariq, let's have a look. For food production use as ingredients in very small part of bulk production, is it possible to assess the risk of all steps as PRPs and OPRP and not have any CCP, but due to insufficient control step can be considered and treated as a CCP?
Okay, I'll have to read this one.
It's quite complex, the question itself.
So, for food product use as ingredients, okay, so sort of like a half finished product use going, in very small part of bulk production. Is it possible to assess the risk of all steps as PRPs and OPRPs and not any CCP considered? I'm not too sure on this one. I'd need to.
Okay.
Yeah. Manuel's asking, are there any examples of processes without any CCPs? I remember it was the longest thread ever on the IFSQN discussion forum of, can a process have no CCPs? And after hundreds and hundreds and hundreds over many years, the answer is yes. There can be processes without CCPs, definitely. Yeah.
Okay. Noel's just said, for magnets, we measure the number of pieces and their sizes, choking hazards, to help establish limits. Depends on the type of magnet, what you will find on the magnet. Rare earth magnets will collect dirt as well. Apart from decision trees, are there any other tools, Patricia's asking, to determine CCPs? Or is that just the standard method? Yeah,
good question. So I think the most common tool, yes, is decision trees. But as mentioned by Codex, you can actually now maybe employ a different tool for determining if something is a CCP. That's something I would have to actually research what other tools there are to help you determine if something's a CCP. But yeah, that's a good question now, especially with Codex saying you don't have to use a decision tree, you can employ something different. Yeah.
And Noel's obviously an expert on magnets. He's put, use pull tests to verify the strength of magnets and then send the pull test kit for calibration for validation.
Yeah.
Thanks, Noel. Difference, Justin's asking, difference between a quality control point and an operational prerequisite procedure.
Yes, so quality control point, as an example, could be labeling. So labeling their final product, the label is correct, has the correct, information. For some people, that is a quality point, quality control point. This is actually something, like the category of quality control point is something that we would see a lot with companies has plans on sort of like Australia, New Zealand side of the world. They sort of would use this term more often than this side of the world here. And of course with FSMA, that's a whole other story that I didn't go into that today. That's for another session. But yeah, quality control point, for example, could be labeling of a product. Yeah.
Okay. Sophie said downgrading can be possible based on risk assessment. Yeah, as with everything, risk assessment is the key. Seth, is the term OPRP only used under ISO? Can you explain the difference between OPRPs and preventive controls?
So So yeah, ISO 22000, it brought in that term OPRP. Can you explain the difference between OPRPs and PCs?
Preventive controls.
Preventive controls. Yeah, this is a term under. We're moving to. We call them PCP plans, so preventive control plan. So slightly different to a your standard HACCP plan, which we're kind of been more referring to today, and obviously was brought in under FSMA regulation in the US. So preventive controls. Maybe again, just briefly, under the FSMA regulation, it sort of brought in these list of sort of preventive controls that you need to have in place sort of before you go and you start doing your hazard analysis, like supply chain management or supplier control, cleaning and sanitizing. They sort of brought these in, and they would be considered preventive controls. Again, it will, again, we'd have to go into that in more detail, look at the process and the product.
Yeah. Okay. Bruce has just mentioned to Leonard, the US FDA do not recognize PRPs or OPRPs and therefore require the preventive control analysis to be done in the absence of these. This applies under FSMA and therefore does apply to foreign supplier verification.
Yeah.
Okay.
Exactly.
So from Vanessa, can pasteurization be considered a CCP when it cannot remove the toxin produced by the bacteria formed due to the failing of the OPRP temperature control of milk? Are you au fait with milk processing at all?
So obviously pasteurization is there firstly to deal with your biological hazards that you identify, like salmonella and listeria. And then the what we've mentioned here is toxin produced. So toxin produced by the bacteria formed due to the failing of an OPRP, like temperature control of milk. Again, a tough question.
Yeah.
So that's kind of, it still is a CCP because it is controlling, specific hazards like maybe salmonella or listeria. When it comes to that toxin, it is kind of a chemical. So when you're doing your hazard analysis, you're looking at your biological, chemical, physical, allergen hazards. Yeah. So it still is a CCP because of the biological. When it comes to the toxin, I'm not too sure what might be put in place to control that.
Yeah.
But there might be something else at that point or somewhere else. Yeah.
Okay, yeah. Nicole's just mentioned, where are we? Broker control, potentially the seals on the truck, ensuring all noted on the bill of lading are present, recording their presence and those removed at time of receipt. So there's some controls for brokers. And Sophie has mentioned the certificate of analysis to release finished products can be OPRPs with likely transport temperature as a CCP for a broker. Yeah, so yeah, transportation. Yeah, temperature controlled transportation. Okay. Geez, so many questions. Wow. Have you ever worked in a bakery? Can you? No. An example of an OPRP in a bakery plant?
I'm not too familiar.
Depends what they're baking.
Yeah.
What the steps baking are. Bread, but if they're making, some bakeries bake things that have meats in and all sorts. Okay. So Rose, PRPs are mentioned in ISO 22000 series. Is this correct? So when the food safety system is based on Codex HACCP, is it acceptable to identify a control measure in an OPRP in the conduction of the hazard analysis?
I do believe so, because when the Codex decision tree, it only considers if something is a CCP. It doesn't tell you how to manage something that is not considered a CCP. So yeah, I would, in my opinion, if you want to identify something as an OPRP and you're working, you might not be working directly under ISO, but I think that's still okay, to be honest, because Codex just, you answer your questions, it's just considering CCPs. It doesn't take into account PRP or OPRP. So yeah, I think you can, especially now they have no decision tree, so you can use what you want, I think. Yeah.
Okay. Venugo Pala Chris Murphy, sorry if I've got your name wrong, says personal hygiene and cleaning hands is an OPRP in a bakery. Okay. Narangachai saying new codex requires GHPs. GHPs need greater attention and CCP.
That's true, yeah.
Okay. Nasser's just saying a great learning event. Really thankful to Anne-Marie for her professionalism, especially when a question was asked, she answered properly or said that this is something to explore. Not very common, as presenters seem to know everything or pretend to know everything. I mean, are there some additional resources on the Safe Food 360 website pertaining to this subject?
Yes, there is. There is a white paper, and there's also a blog on the website. So the white paper I'm referring to, I think it's called Determining Control Measures. So it actually goes through decision trees in a lot more detail than I did today. There's a few different examples in there.
So should we, in the follow-up email, should we put a direct link to that white paper? That would help.
Yeah.
And then I guess if people rewatch the video and the presentation and read the white paper and then have questions, can they submit them through Safe Food 360 website?
Yeah, if they have a question for me, they can just mention my name.
Yeah. So because we're not going to be able to answer all these questions again, because there are just too many, which is great. But what we'll do is we'll funnel that into Safe Food 360 so to provide you with more information and then filter that. And if you still have questions, then you can contact Anne-Marie through the website. Okay. Another question, is there a HACCP plan or system without a single CCP? Yes, we've said that. Mario's asking, can FMEA be used, failure mode effect analysis, to determine CCPs as an alternative? Have you used FMEA? No. It's it's used when designing products and things, but not normally in the food industry. Okay. So Narangachai said BRCGS Food Issue 9 will be revised to include the new Codex concepts. Sophie, toxins are of protein's nature and are temperature sensitive, so easily destroyed by high temperature. CCPs in milk production, are you aware of any? As you said before, I guess pasteurization.
Yeah. Metal, it could be metal detection.
Yeah. Okay. Are you familiar with another acronym, SPP? So Kalim Mullah is asking, What is the difference between OPRP and SPP, special prerequisite program?
I haven't come across this term, but it's sounding a bit like an OPRP, but I wouldn't, I haven't come across this term just yet.
Okay.
Yeah.
Claudia, I would guess that sieving flour in a bakery will be an OPRP. Yeah, that's a good one.
Yeah.
Okay. One from Lashangabam. In a liquor bottling plant, final inspection point is considered as CCP and foreign matters like glass pieces are considered as hazards. Can we consider small fiber particles as hazards?
Yeah, it's a physical hazard. Fibers, now, I'm not too sure the fibers, where they might be coming from. But yeah, if you've identified that as a hazard, yeah, there's lots of different foreign matter hazards. Yeah.
Okay, Susan, helping on the bakery. Temperature of cream in filling donuts could be a bakery PRP. Yeah, good point. Barry's put the link there. Hopefully you've all seen it, to the blog. And as I say in the follow-up email, we'll put a link to the recording, the slides, your certificate, the white paper, everything. So you'll have that in your inbox within an hour or so. And Barry's put the white paper as well. So there we go. Let's see. Lee Weiwei. Is an OPRP, can an OPRP be changed to a CCP if there is frequent failure in the former? If not, what will be the approach in order to have an effective OPRP?
So is can an OPRP be changed to a CCP if there is a frequent failure? I mean, the CCP will need to have defined critical limits. We need to be able to measure, and if there is a failure, we should be able to detect it within in a timely manner. And if you can't do that, then it's an OPRP. So if we look back at the decision tree, and sort of the definitions around failure. So if there's a frequent failure, I mean, it'll still be an OPRP. And I mean, it can't really be changed to a CCP unless there's critical limits there.
Yeah.
Yeah.
Okay. Bernard, pest control in a bakery is important. We're actually doing like a hazard plan for a bakery here. It's good.
Yeah.
Are you familiar with risk software from the FDA? That's from Maxine.
Risk software
from the FDA.
No, not exactly.
No. You're
They-
very familiar with SafeFood 360 software.
Yep. Yep. I know Barry's here as well, but he won't he'll give out to me if I don't mention, but we do have a new tool for risk called Risk coming to SafeFood 360. So that is something just to make note of. But yeah, not too familiar with the tool in the FDA.
C. David says, if there is frequent failure, root cause analysis has to be done. Yeah. Why is it failing? Good, that's a good point.
Yeah.
Manoj, examples of OPRPs in hotels?
Good question.
Guess catering's the main, the restaurant, etc., is the main thing, isn't it?
Yeah. Yeah, I can't think of one right now, to be honest. Those HACCP plans in the catering industry sometimes are a little bit different to the ones in the mainstream food industry. So I'd have to research it myself to help answer that.
Okay. Critical limits for metal detection. That's from Lizani.
Critical limits. So, again, well, you can have 3 different metal wands that you will send through your metal detector to test it. So we got, different sizes, but ferrous, non-ferrous, and stainless steel.
Yeah.
So, yeah, have to look it up.
Yeah. Okay. And a few people have mentioned, the main things in hotel sort of catering is sort of cooking, cooling, storing, temperatures and things like that. So yeah. So Betsy's just confirming what you said. The critical limits for metal detection depends on the product and the size of the ferrous, non-ferrous, stainless steel, etc. So yeah. Okay. Right. Yeah, Sophie, restaurant OPRP, the buffet temperature. Yeah, sure. Okay. I've gone through and picked out, and I know Barry's now sent me by email the links he's just put in the sidebar, so I can add those to the email. Right. Go on, let's take one more from Maribel. And in case we make an OPRP plan similar to the HACCP plan, components will be most likely the same with the HACCP plan, except that there will be no critical limits, ?
So in your HACCP plan, you can have a mixture of OPRPs, CCPs, and obviously your PRPs as well. Again, OPRPs, if you do identify one, they don't have to have critical limits. You can still manage your OPRP as a CCP with critical limits if you wish, but I'm not too sure or maybe on the question.
Okay. No worries. Mario has made a comment there. Maybe we slipped through all GFSI certifications since 2009, but the FMEA, failure mode effect analysis, was always accepted. Maybe it's not the typical FMEA method we apply, but we assess process steps and achieve a risk priority number, RPN, severity of the event, probability of the event occurring, detection, probability that the event would not be detected before the user was aware of it. Depending on the number, we determine CCPs. So far, BRC IFS since 2013. Yeah, FMEA is used in all sorts as a real robust risk assessment, deep tool. But so thanks, Mario. Yeah, it's worth looking up, FMEA. Yeah. It's a very good tool. Okay. Praveen, a bit off topic. What is the difference between HACCP and VASP and TACCP?
So HACCP is all about identifying your hazards within your process or within the product you're producing. VASP is your vulnerability assessment, and sort of the same as TACCP. So more about identifying, for instance, at your step of mixing, could somebody come in and just add anything into it? So it's sort of more about adulteration of your product through its process, essentially.
Food defense. Yeah. Okay. Thanks, Naray. Bless you. I need to sanitize my hands now. I'm on my own here, so okay. Martha, thank you, very helpful. Okay, right, we've gone 20 minutes over, so fabulous presentation. Lots of quite complex questions, very process specific, so some of them are quite tough to answer. So you've done well there, Anne-Marie. Thanks very much. So what we will do is, as I say, we'll follow up with the recording, the slides, and the links and the certificate, and then yeah, everybody will be happy. So thanks very much for your time today, Anne-Marie, and have a great weekend, and hope to see you on one in the near future.
Thank you, Simon. Thank you all for joining.
Thanks. Thank you. And there were 700 and something at one point online. So amazing. Brilliant. Thanks, Anne-Marie. Bye-bye.
Bye, everyone.
Okay, guys, I'll load your certificate in the sidebar. That's certificate of attendance. So you can go and grab that now. It'll open in a new window. If you print it, sign it yourself, or open it in a package like Paint and just type your name into it and save it as an image. Okay, so thanks for joining. We've had a few weeks away over the summer, but we're back next week with another Food Safety Friday. So hope you attend then. Thanks for engaging with this one. Take care. Have a lovely weekend. And let's hope it's a nice, long and peaceful one. Take care, everyone. Bye.